Hello students, today the topic is leaf. Okay, so this is the third topic in the morphology of flowering plants. Okay, first we discussed about the root and then we discussed about the stem. Now it is the turn of leaf. Everyone knows that the green colored parts which you will find on the stem as well as on the branches are leaves, and these are the main photosynthetic organs of the plants. Okay, but let us discuss them in detail. First, let us see the general characters of the leaf. The first one is the first character is the leaf is an organ of limited growth. Leaf is an organ of limited growth. What does it mean? Remember that some parts of the plants will grow continuously, so they exhibit unlimited growth. What are those organs that exhibit this continuous growth or unlimited growth? Root and stem. So the root and stem will grow continuously throughout the life of the plant. So that means this root and stem will grow till the death of the plant. But whereas the leaves are organs of limited growth, means what you might have observed. The leaf will, in the beginning, the leaf will be very small, light green in color, and as it is maturing, it becomes a dark green, and later, by the time it becomes old, so you will find that the leaf will turn yellow, and later it becomes brown, and after that, you will find the leaf on the ground. That means what? The plants are shedding the old leaves or senescent leaves. Means what? The leaf is not a permanent organ. Okay, and it after reaching some maturity, after reaching some maximum size, it won't grow further. So that's why it is an organ of limited growth. I hope you're understanding. But let us generalize this. So remember, what are the organs of unlimited growth? Root and stem. Then what are the organs of limited growth? Leaf, flower, fruit, and seed. These are organs of limited growth. Okay, so that is the first character. And the second character is their lateral flattened structures. Lateral means what? Where you will find these leaves? So if you take the stem, so do we find the leaf on the top of the stem? Or do we find the leaf at the base or bottom of the stem? No, you will find them on the sides. Okay, so that's why it is lateral, and of course you know that it is expanded one. Okay, means what? Flat structure. It may exhibit the two surfaces very clearly, as in the case of dicots, and we call the leaf as what? Dorsiventral leaf. And if both surfaces are alike, as in the monocot leaves, we call the leaf as what? Isobilateral leaf. And sometimes the leaves may be cylindrical, and we call them as what? Centric leaves. Like that, different types of leaves are there. So, but when we generalize the things, they are lateral flattened structures. Okay. And the third character is from where they develop. Okay, you can look at the diagram. They develop at a particular place which is called node. Develops at the node and bears a bud in its axil. So you will find a bud here. And what we call this bird? Axillary bird. Axillary bird. So remember, this is the angle. So we can say the upper angle between the axis and the leaf is called axil, and the bud that is present in the axil of the leaf is called axillary bud. Okay, and of course, this axillary bird will later will grow into what? A branch. Okay, so that is the normal function of the axillary bird. But during reproductive phase, the same axillary bird may produce a flower or an inflorescence. So that's what you have to understand. Okay, and now let us say the next one. Leaves originate from SAM. What is SAM? Shoot apical meristem. Leaves originate from shoot apical meristem. Means what? If you take the shoot apical meristem, it is composed of meristemary tissue and is protected by the leaves. Means who produce these leaves? This apical meristem itself. And what you call this apical meristem? Shoot apical meristem. But remember that where you will find this shoot apical meristem? It is associated with terminal bird as well as axillary bird, because while stem is growing, that also produces leaves with the help of terminal bird, and even when the branch is growing, so that also produces leaves with the help of its bird at the tip. But what was this axillary bird then? So don't forget this thing, that this axillary bird, whenever it becomes a branch, where you'll find that axillary bird now? When it becomes a branch, you'll find this axillary bird at the tip of the branch. So the same axillary bird is becoming what? Terminal bird of the branch. While it is growing, it is producing what? Leaves. And you remember that continuously it produces as the branch is growing or as the stem is growing. That's why, remember that the older ones will move downwards, and whereas the younger ones will be at the apex. And you see, that's what the fifth character. They are arranged acropetally or acropetal succession. What is the meaning of this acropetal succession? So, simple thing is that the older ones at the base and the younger ones at the apex. This is called acropetal arrangement or acropetal succession. So that is the fifth character, and the sixth character everyone knows. What is that sixth character? It is the most important organ for photosynthesis. But of course, I want to add one more thing. Not only for photosynthesis, even the main transpiring organ of the plants is okay, leaf only. Okay, the most important organ of photosynthesis as well as transpiration and transpiration, that is better. Okay, these are the general characters of uh, the leaf. And then we will discuss about this one, parts of a typical leaf. What is this typical leaf? This is what an example leaf or a model leaf. Okay, because here we find all parts, but all these parts may or may not be present. I am talking about some parts. Okay, that we will discuss now. Now let us discuss about these parts of a typical leaf, and there are three main parts in the leaf. Three parts. They are from base to the apex, leaf base, petiole, and lamina or leaf blade. Leaf base, petiole, lamina or leaf blade. These are the three parts of the leaf. And of course, remember some technical terms are there. Then this leaf base is also called as hypopodium. Hypopodium. And the petiole is called mesopodium. And the lamina is also called as epipodium. And this hypopodium, mesopodium, epipodium, they are all together parts of the entire leaf, and the entire leaf is called phylopodium. Phylopodium. That is leaf. So the phylopodium is having three parts. Let us use those technical terms. First, at the base, hypopodium. At the top, epipodium. And the middle, mesopodium. I hope now you are understanding. Hypo means below, epi means above, meso means what? Middle. Okay, these are the parts. And what is the function of the leaf base? Okay, you can see the parts here. So this is what leaf base. And what it is doing. And it will help in the attachment of the leaf. To who, which one? Okay, stem or the branch. I wrote stem or branch because you will find leaves not only on the stem, even on the branches. And the place is called what? Node. Okay, and that is attachment. And what is the petiole? The stalk-like structure present between the leaf base and the lamina is called what? Petiole. And what is the function of this petiole? And of course, don't forget this lamina is the expanded portion of the leaf, and it should be exposed to the light perfectly. Okay, that's why this petiole will lift this leaf towards the light. So that is the function, and not only that, and from these vascular tissues will enter into this, and which will supply water, the xylem. So the vascular tissues or conduction is also happening through this petiole. So the petiole will conduct water and minerals to the lamina, and in return it will bring the food materials that are prepared by the lamina to other parts of the plant. Okay, that is the petiole. And the next one is what this lamina or leaf blade, which is the terminal part of the leaf, and which is a expanded one. Okay, and it is showing some lines here, and what are these? Okay, veins and veinlets. And what we call this arrangement of veins and veinlets in the lamina, we call it as what? Venation. Of course, among these, you can see one thick vein is here, and that is called midrib or midvein. And it is producing some branches, and the branches are called what? Lateral veins. And what you call this one? The leaf margin. And what you call this tip of the leaf apex. But of course, remember that this is a model leaf, and don't think that all leaf margins will be like that. Leaf margins will vary from plant to plant. In the similar way, even the leaf apex is not same in all plants. So the leaf apices also vary from plant to plant. So like that. But in addition to that, you will find some leaf-like appendages here. And the leaf-like appendages which are present on either side of the leaf base are called stipules. Okay, and as I told you that this is a model leaf and it is showing all parts. But remember that a leaf will have two parts will be there. Okay, compulsorily. And what are those two parts you will find in every leaf? Leaf base and the lamina. But the stipules may or may not be present. Petiole may or may not be present. So that's why, based on the presence and absence of these stipules, when they are present, we call them what? We call the leaf, or we describe the leaf as what? Stipulate leaf. When stipules are absent, we call the leaf as what? Exstipulate leaf. In a similar way, the petiole may or may not be present. So, when the petiole is present, or the leaf with petiole is called petiolate leaf. And when petiole is absent, the leaf is called sessile leaf. Okay, now I hope you're understanding. So the leaf with petiole is described as petiolate leaf, and the leaf without the petiole is called what? Sessile leaf. Then we get one doubt here. Already we have come to know that the petiole is helping in exposing the lamina, and here the sessile leaf is lacking this petiole. Then how the lamina will be exposed? Then you have to understand one point here. So all plants do not produce the branches, means what, in a crowded fashion. Only in some plants the branches are crowded. In such case, the petioles are required. And some plants will produce few branches which are already exposed, okay, and which are not overlapping with each other, and because of which every leaf is getting sufficient amount of light, and then where is the need of petiole? So in such cases, so the leaves generally lack the petiole. Then we describe such leaves as what? Sessile leaves. Okay, and then what about this function of this stipule? The stipule will help in the protection of axillary bird. It protects the axillary bird. Again, we get a doubt. And here also some are without stipule. Then how the axillary bird will be protected? Actually, remember only the axillary bird is composed of what? Meristematic tissue, and is already protected by, okay, so these leaves, young leaves, which are called primordial leaves. So when stipules are present, they are providing what? Extra protection to the axillary bird. So that is the thing, and of course the leaf bases are of many types, and let us say two variations in the leaf base. One is sheathing leaf base. Sheathing leaf base. Another one is pulvinous leaf base. Okay. And okay, and the example for the sheathing leaf base, what the grass leaves. I hope you might have observed the leaf of the grass, which are linear leaves like this. So now I would like to tell you this portion is the lamina. This is the lamina, and this is the leaf base. And actually, not only from here to here, from here to here, the whole thing is what leaf base. And so whenever you come across with a grass plant, very easily you will find this grass, and you just look at that plant, and you will find the leaf at the lower portion is surrounding the stem, and it is surrounding the stem with the help of this sheath like leaf base, and it is to protect the intercaled meristems. So these sheathing leaf bases are present in grasses. Okay, so in grasses you will find these sheathing leaf bases. And of course, I hope you know in Mimosa pudica, which is commonly called as what touch me not plant or sensitive plant. And whenever you touch the leaves, so the leaflets will fold. Okay, and as soon as you withdraw your hand, so they will become normal. That's why we call the plant as what? As touch me not plant or sensitive plant. And did you observe the leaf base there? The leaf bases will be like this. Means what? They will be swollen. Such swollen leaf bases are called what? Pulvinous leaf bases. And not only Mimosa pudica, generally this is a characteristic feature. Pulvinous leaf base is a characteristic feature of all plants belonging to Leguminosae family. Okay, and of course, now we are not using this word Leguminosae because Leguminosae was the family under which three subfamilies were used to be there, and now the subfamilies are given the rank of family. So that's why we are using the family names like what we are familiar with one family which is there in our syllabus, that is what Fabaceae. And you remember one thing, all pulses belong to the family Fabaceae. Fabaceae and Cisalpinaceae and Mimosaceae. In these three families, you will find these pulvinous leaf base. These are certain variations in this leaf base. Okay, and the next aspect we will discuss in the next video, that is what about this venation.